3,000 light-years away from Earth in the constellation Valens, astronomers have spied a black widow lurking in space, tearing apart and consuming its companion star. And it's a record-breaking cosmic object, the Black Widow, which scientists say is the heaviest neutron star ever found. Weighs more than twice the mass of our Sun, making it the heaviest neutron star known to date. The object also spins 707 times per second, making it one of the fastest spinning neutron stars in the galaxy. So what exactly is going on here? How did this neutron star gain so much weight? And why do astronomers call this object a black widow? We've got the answers. But first, a word from today's video sponsor. The world's most powerful countries are racing to develop quantum computers, machines that harness the power of quantum mechanics to perform calculations in ways that would take classical computers millions of years. By exploiting quantum phenomena such as superposition and entanglement, quantum computers could revolutionize fields like medicine, materials science, and artificial intelligence by solving problems that are currently intractable. Now back to the Black Widow. Black widows are named after the infamous arachnids known for female spiders that consume much smaller male partners after mating. And our Black Widow is no exception. It's consumed almost the entire mass of its partner star, allowing it to become the heaviest neutron star we've observed. Neutron stars form when massive stars collapse at the end of their lives. Normally, the star's core is squeezed into an incredibly dense sphere only a few miles across, because matter is mostly empty space. This means that the collapsed core of the star is extremely heavy. 1 teaspoon of neutron star material weighs billions of pounds. But our Black Widow neutron star, known as PSRJ 09520607, is extra heavy. It weighs in at 2.35 times the mass of the Sun. It's not quite a black hole, which have infinite mass, but it's close. To get so heavy, the neutron star must have devoured most of its companion star. To learn how massive the neutron star is, astronomers turn to the sensitive Keck telescope at the W.N. Keck Observatory on Mauna Kea in Hawaii. The companion star is now about the size of a large gaseous planet, or 20 times the mass of Jupiter. The side of the companion star that faces the neutron star is heated to 10,700 degrees Fahrenheit, 5,927 degrees Celsius, hot and bright enough to be seen by a telescope. With this new mass measurement, astronomers have updated the object's entry on the Guinness Book of World Records, bumping up its mass to a new record of 2.35 solar masses. That makes it the heaviest neutron star that we've ever found. It's also the densest object within sight of Earth. 1 cubic inch 16.4 cubic centimeters of a neutron star weighs more than 10 billion tons. According to study author Roger W. Romani, a professor of physics at Stanford University in California, we know roughly how matter behaves at nuclear densities, like in the nucleus of a uranium atom, said study co-author Alex Filippenko in a statement. Filippenko holds dual titles of Professor of Astronomy and Distinguished Professor of Physical Sciences at the University of California, Berkeley. A neutron star is like one giant nucleus, but when you have 1.5 solar masses of this stuff, which is about 500 Earth masses of nuclei all clinging together, it's not at all clear how they will behave. The team plans to continue monitoring the system to see if it continues to pull material from its companion. Neutron stars that feed on their companions are known as pulsars because as they spin, the objects act like a cosmic lighthouse, regularly beaming out light through radio waves, X-rays or gamma rays. Normal pulsars spin and flash about once a second, but black widows can spin hundreds of times per second. That's because as the neutron star devours material from its partner, it becomes more energized. The fastest spinning neutron star ever found is another Black Widow candidate, which goes by the catchy name of Fast J1748 to 2036 AD. It was identified in 2020 and spins a mind-boggling 1,300 times per second. At this rate, the doomed companion star will eventually be completely stripped, leaving the Black Widow neutron star to cool off and fade away. In a case of cosmic ingratitude, the Black Widow pulsar, which has devoured a large part of its mate, now heats and evaporates the companion down to planetary masses and perhaps complete annihilation. Filippenko said. Astronomers first discovered the neutron star in 2017, and Filippenko and Romani have studied similar black widow systems for more than a decade. They have been trying to understand how large neutron stars can become. If neutron stars become too heavy, they collapse and become black holes. So understanding where the boundary lies between a maximum mass of neutron stars and the minimum mass of black holes is a major question in astrophysics. Some physicists think the boundary occurs round to times the mass of the Sun, while others believe neutron stars can get even heavier. The current study lends support to the lower estimate because it suggests that a neutron star with a mass of 2.35 times the mass of the Sun is right on the edge of collapsing into a black hole. We can keep looking for black widows and similar neutron stars that skate even closer to the black hole brink. But if we don't find any, it tightens the argument that 2.3 solar masses is the true limit, beyond which they become black holes, Filippenko said. It's unclear exactly how many black widows exist in the Milky Way. Astronomers may be able to spot dozens more with upcoming surveys, but they suspect that these systems aren't all that common. Still, finding them is important because every black widow tells us something new about the inner workings of neutron stars, and neutron stars are already teaching us some surprising lessons. For example, astronomers recently discovered that a neutron star can be kicked out of a galaxy by a supermassive black hole. It's the first time we've ever spotted such an event. Because these objects are so dense, neutron stars are very sensitive to changes in their environment. When they leave a cluster of stars, they begin slowing down quickly. It usually takes tens of millions of years for a neutron star to slow down to normal speeds. But in this rare case, it happened in just a few million years. It has thought that a large kick imparted on the neutron star by the black hole caused the slowdown. Such kicks are relatively common when two objects merge, said study leader Danny Milosavljevic, an assistant professor of physics at Purdue University in West Lafayette, Indiana. When two things merge, they don't stick together perfectly. There is some kind of jostling. In the case of the neutron star and the black hole jostled the neutron star hard enough to kick it out of the galaxy. It might seem counterintuitive, but neutron stars are actually pretty easy to spot. Their bright flashing light makes them stand out against the backdrop of space. Thanks for watching this episode. And if you want to help us make even more videos like this, you can join our community on a crowdfunding platform. The link is in the description below. All the best and see you next time.